Hi, this is Josh from Over the Shoulder Coding, and I'm going to go over Leetcode problem today for number 155, minimum number of vertices to reach all nodes. So this is today's daily problem, and we're going to try and tackle it in about 15 minutes or so. Let's get started. So given a directed acyclic graph with n vertices numbered from 0 to n-1, and an array of edges where the edges are also an array from I to I, represents a direct edge from I to node 2i. Okay? Find the smallest set of vertices from which all nodes in the graph are reachable. It's guaranteed that a unique solution exists. And notice that you can return the vertices in any order. So we have an example here. Input is n equals 6. Edges is a 2D array 0, 1, 0, 2, 2, 5, 3, 4, 4, 2. And they've helped us visualize this. There's an edge 0 to 1. Edge 0 to 2, 2 to 5, 3 to 4, 4 to 2, and the output is 0, 3. So it's not possible to reach all the nodes from a single vertex. From 0, we can reach 1, 2, 5, and 0, and from 3, we can reach 3, 4, 2, 5, so we output 0, 3. So if we need to reach all the edges, we need to start from 0 and 3. And the second example, input n equals 5. Edges are 0, 1, 2, 1, 3, 1, 1, 4, 2, 4. So we have 0, 1, 2, 1, 3, 1, 1, 4, and 2, 4. And there's nothing feeding into 0, 2, or 3. There's things feeding into 1 and 4. So the output is 0, 2, 3. Notice that vertices 0, 3, and 2 are not reachable from any other node, so we must include them. Also, any of these vertices can reach nodes 1 and 4. Got it. So we have to start from at least 0, 2, and 3. And we're going to have less than 100,000 nodes. The edges will have fewer than 100,000 edges or all possible nodes connected. The edge will be linked to 0 from the edges will all fall within the nodes, and all edges are unique. Okay. Cool. So here they're already saying set. So in my mind, in Python, we're going to use a set class to return the set of vertices. So we can track and remove vertices from the set. So just to make sure we can handle the nodes and edges. And then I think we'll create a set of all nodes and then iterate over the edges and remove nodes when we can access them. So when there is a path from 0 to 1, we can remove 1 from all of it and then return list of starter nodes. So just to handle the input, so let's make sure we can handle this. And we'll return a list. Now let's run this and see what happens, just to make sure we're handling the inputs correctly. So here we're messing up a little bit. Let's try it again. All right, so we are detecting 6 nodes and 5 edges. So we can create a set of all nodes. And let's just use this as starting nodes because we're returning at the end of the nodes we have to start from. And iterate over all the edges and remove nodes when we can access them. So here for edge, in edges, if, so we have from, which is the first index of an edge, and to is the second index of an edge. From is a reserved word, so I'll use source and destination. If the destination is in the set of starting nodes, we'll remove it. Otherwise, we'll keep iterating over all the edges. And here I'm just going to print the list of nodes I can print it after each time we remove just to check what's going on. And here, why don't I just print the edge that we're going for? So if I run this and I iterate over all the edges, so I'm not getting anything here because the set is empty. I need to populate the set from all nodes. So for I in range n set dot add I. So then our set will be populated. Let's just make sure. Let's run it, see what happens. Am I using the wrong syntax? Alright, so I need to use starting nodes.add. So we start with all the nodes, we iterate over the edge from 0 to 1, so we remove 1 because we can access it, so remaining nodes looks like this. And as we iterate over the next edge, we remove it as well. We remove 5, we can access 4, so we remove that. And now we're at 0, 3. And we have this edge 4 to 2, but we've already removed 2, so this looks right to me. And so I can just return a list of all the starting nodes and see if this works. All right, so it works. Let me submit and see how we did. I'm printing too many things, so why don't I delete, or I could even comment out my print statements, but I'll just delete it right now. All right, looks like we were able to solve everything. We did a pretty okay runtime and memory, so not amazing, not terrible, but we're able to solve this in linear time because we're iterating over n nodes and the length of all edges. So worst case scenario, we are still always going to iterate over all the edges once, which is pretty okay. The memory we take up is just the set of all nodes, which also isn't huge, and I think this is a pretty reasonable solution. We did it in maybe sub 10 minutes. So this probably, if you see this as part of a coding problem, you'll probably have multiple coding problems or multiple parts of this where this is just one part. But I think this is a pretty straightforward solution. So if you have any questions, the source to this is in the description. There's a link to that, or just comment and let me know if you have any questions. Thanks.